cursor is a pointer to a private SQL area that stores information about the processing of a select or data manipulation language, DML, statement, insert, update, delete, or merge. Cursor management of DML statements is handled by Oracle Database, but PL/SQL offers several ways to define and manipulate cursors to execute select statements. To execute a multi-row query, Oracle opens an unnamed work area that stores processing information. A cursor lets you name the work area, access the information, and process the rows individually. Here are some of the examples of cursor statements. Using the select into statement. Fetching from an explicit cursor. Using a cursor for loop. Using execute immediate for dynamic queries. Using cursor variables. Each SQL statement has one parent cursor, one or more child cursors. Parent cursor stores the SQL text of the cursor. When two statements are identical textually, they will share the same parent cursor. $area contains one row for each parent cursor. Child cursor. Each parent requires at least one child cursor but can have more than one child cursors. The child cursor holds other required information, like the identity of the objects referenced by the SQL cursor, the names, type, and length of the bind variables used. Child cursor contains environment, statistics, execution plan, bind variables. $SQL contains one row for each child cursor. A child cursor takes up less space in the cursor cache. A child cursor doesn't contain all of the information stored in a parent cursor. For example, the SQL text is only stored in the parent cursor and not in each child. The first child cursor is numbered 0, the parent, then 1, first child, then 2, and so on. They are simply cursors that reference the same exact SQL text, but are different in some fashion. It is important that SQL statements should use the same cursor. E.g. select asterisk from department and select asterisk from dept. If we have two textually different SQL statements, two parent and hence two child cursors will be created since the two statements are textually different. If we have two textually identical statements with different bind variables, only one parent cursor will be created but multiple child cursor. When you have the same statement that has several versions, children, the view $SQL_shared_ cursor shows the reason why the statement cannot be shared. You may be able to find that for each child cursor except the first one, why it was not possible to share a previously created child cursor. For several types of incompatibility there is a column that is set to either N, not a mismatch, or Y, mismatch. Parameters related to cursor are cursor_sharing, open_cursors, session_cached_cursors, cursor_space_for_time. Cursor_sharing determines what kind of SQL statements can share the same cursors. Force allows the creation of a new cursor if sharing an existing cursor, or if the cursor plan is not optimal. Similar causes statements that may differ in some literals, but are otherwise identical, to share a cursor, unless the literals affect either the meaning of the statement or the degree to which the plan is optimized. Exact only allows statements with identical text to share the same cursor. Open_cursors specifies the maximum number of open cursors, handles to private SQL areas, a session can have at once. You can use this parameter to prevent a session from opening an excessive number of cursors. It is important to set the value of open_cursors high enough to prevent your application from running out of open cursors. The number will vary from one application to another. Assuming that a session does not open the number of cursors specified by open_cursors, there is no added overhead to setting this value higher than actually needed. Session_cached_cursors specifies the number of session cursors to cache. Repeated parse calls of the same SQL, including recursive SQL or PL/SQL statement, cause the session cursor for that statement to be moved into the session cursor cache. Subsequent parse calls will find the cursor in the cache and do not need to reopen the cursor. Oracle uses a least recently used algorithm to remove entries in the session cursor cache to make room for new entries when needed. Session underscore cached underscore cursors is used to improve the performance of soft parse. Cursor underscore space underscore for underscore time. Cursor underscore space underscore for underscore time lets you use more space for cursors in order to save time. It affects both the shared SQL area and the client's private SQL area. Accepted value for this parameter are true or false. False, shared SQL areas can be deallocated from the library cache to make room for new SQL statements. True, shared SQL areas are kept pinned in the shared pool. If you are using application contain lot of cursor, it will be good to set it to enhance execution time. To do that, shared pool must be large enough to hold all open cursors simultaneously. Most users will not need to set this parameter because of the significantly enhanced concurrency modifications. The cursor underscore space underscore for underscore time parameter is deprecated. It is retained for backward compatibility only.